Welcome to episode 4 of the P2P Connects Us podcast. I'm your host, John Light, and on today's episode, we're going to be talking about San Francisco's new home sharing law, FireChat's new verified names feature, SyncThing joins the indie ecosystem, Wall Street Journal promotes a decentralized internet, and last but certainly not least, Greg Silpak of DNS Chain and OK Turtles joins the show to talk about peer-to-peer identity technology. Hello, and welcome once again, ladies and gentlemen, and everyone in between, to episode 4 of the P2P Connects Us podcast. I would like to thank each and every one of you for tuning in to this week's episode when you could be doing anything else with your valuable time right now. I have a few announcements to make before we get on to the substance of the podcast. I would like to announce that the second P2P Connects Us sponsor token auction is now live at auction.letstalkbitcoin.com. Bid now using LTBcoin for your chance to advertise for the P2P project of your choice on the P2P Connects Us podcast. The last auction closed at 133,337 LTBcoin. Will we set a new watermark? Will the winner make off with a bargain? Bidding starts at just 10,000 LTB coin. That URL again is auction.letstalkbitcoin.com. Twitter users can follow the Twitter feed of the show by following at P2P Connects Us, where I post interesting stories from the world of P2P that may or may not make it onto the podcast. You can also tweet me stories you'd like to see covered on the podcast, guest interview suggestions, and general feedback about the show. As I mentioned last week, SoundCloud uploads are here. If you're not listening to this on SoundCloud right now, you will be able to do so, if you so desire, by going to soundcloud.com/P2PConnectsUs. I've also begun posting episodes of the podcast on YouTube with a unique Bitcoin tipping address for each episode so I can keep track of which shows people like the most. Tipping is the most reliable metric that I've used so far to track episode popularity, so if you enjoy a particular episode, please send a Bitcoin tip to the address on YouTube or the address listed on the episode page at p2pconnects.us or letstalkbitcoin.com. The magic word for today's episode is OK Turtles. That's OKTURTLES. OK Turtles. You can redeem the magic word at letstalkbitcoin.com for your share of this week's LTB coin proof of participation points. If you'd like to learn more, you can go to ltbcoin.com. With those announcements out of the way, it's time for the news. In San Francisco, politicians and bureaucrats have spent the last 2 years busying themselves with writing the rules for how other people can make use of their own private residences. The result is a new law, passed by a 7-4 margin, which, quote, legalizes and regulates companies like Airbnb, which enable people to rent out space in their homes using a P2P online marketplace. TechCrunch reporter Kim Mai Cutler wrote about the impact the law would have the day it was passed. 1. It limits rentals in non-hosted units to 90 days per year. This, in theory, should cut down the profit margins to a point where you wouldn't hemorrhage additional residential housing units. Rentals where the host is present wouldn't be subject to this limit. So again, non-hosted units simply means that the host is not in the residence while it's actually being rented out. 2. Creates a public registry. Hosts have to pay a $50 fee and register with the city planning department. 3. Hosts have to pay hotel taxes, which Airbnb will remit on their behalf. 4. They have to be covered by liability insurance of at least $500,000 and follow building safety codes. Or they have to offer their listing through a platform that provides equal insurance coverage. 5. They would have to abide by rent control laws. The resident can't charge more than they're paying to their current landlord, which might create all sorts of interesting price distortions in the local Airbnb market. 6. For violations, hosts would get charged increasing penalties for each violation. After repeated violations, they'd be forced to delist, and if they continue, they could be charged civil penalties of up to $1,000 per day. This law is a clear example of the danger of demanding legalization rather than deregulation or decriminalization. Activists have to be careful what they wish for, or they might just get it. Rather than simply undoing all of the laws that made this activity against the law in the first place, San Francisco and other cities that take a legalization approach are imposing barriers to entry, including burdensome regulations and tax obligations, which will raise the cost of using these services and price many people out of the market. I've been covering a similar phenomenon in the P2P ride-sharing industry on the last few episodes of P2P Connects Us, and it's disappointing to see the P2P home rental industry be subjected to the same kinds of government intervention. If the city government wants to get involved in the industry in some way, I think that providing public guidelines and opt-in certification programs for users of these services would be a more meaningful and collaborative way to engage with this emerging economy rather than the strong-arm tactics that we're seeing with this recent law. People obviously want to use these services, and if the regulations are too prohibitive, people will just use private, truly peer-to-peer platforms like OpenBazaar, which enables censorship-resistant, trust-based digital commerce. It would be smarter for governments and industry incumbents to go with the flow of innovation rather than against it. Another example of people using technology to escape government oppression comes to us from Hong Kong, where people have been using a unique mobile app to subvert centralized control of the internet. Open Garden, developers of a proprietary mesh networking technology, recently rolled out new verified accounts feature for FireChat, their P2P chat application. FireChat received a huge swell in its user base when protesters in the Umbrella Revolution pro-democracy demonstrations in Hong Kong began using the app to circumvent government censorship of the internet. With this large increase in users came some degree of chaos. Who is a protester? Who is a government agent? Who is real and who is just a sock puppet? Open Garden hopes to help answer these challenging questions by allowing for both pseudonymous accounts, where users can pick their own usernames, and verified accounts, where people who prefer to use their public personas, such as community leaders, educators, and journalists, can use the app and their audience can be assured that it's really them and not an imposter. So far, the feature is very limited in its use. A company spokesperson said, quote, "We are very careful with the selection process and will grow the number of verified accounts only progressively," unquote. I can see how this feature would be useful, and have also seen requests for additional features that could be helpful in these kinds of protest environments, including IP address obfuscation using technology like Tor, and end-to-end encryption so people can chat privately without their messages being collected by people monitoring the networks. A word of caution to everyone using the app right now. Since all of Open Garden's technology is proprietary, it's hard to trust what's actually happening on the user's device, like whether or not it's working as advertised. Until the source code is released, you have to trust in the developers of the program. I've met many of them myself. They're very nice and intelligent people, but unfortunately there are a lot of bad people out there who could coerce the company into adding a backdoor to their program. Open sourcing the code could serve as a strong countermeasure, since a backdoor would be detected quicker that way. A less secure, though still viable option would be for Open Garden to add what's known as a canary to their website, so that if the canary were removed, people would know that Open Garden and their software was compromised in some way. Just some things to consider for anyone who wants to market a closed source app to vulnerable users like journalists, activists, or even children. On the other side of the spectrum, open source P2P file synchronization program SyncThing has been rebranded as Pulse and is being integrated into the Indie ecosystem. Lead developer Jacob Borg is also joining the Indie team as an advisor to the company. Indie, spelled ind.ie, is based out of the UK and aims to create an open-source, user-centric ecosystem of empowering technologies, including an Indie phone, Indie operating system, and Indie cloud under the banner of Project Stratosphere. Pulse will be a critical component of Heartbeat, the decentralized social networking client that people will use to interact with each other in the Indie ecosystem. Crowdfunding for the project begins in November, so stay tuned for updates. I will try to get someone from the Indie team on the show after crowdfunding has begun so we can learn all about the vision and motivation for Project Stratosphere. If anyone from the Indie team is listening, consider this your invitation. It's not just indie developers and designers who are interested in the decentralization of the internet. Gary's Guide founder Gary Sharma recently wrote an article for the Wall Street Journal's Weekend Read column called The Imminent Decentralized Computing Revolution, wherein he describes the P2P technologies that are forming the foundation of a new internet. He writes, quote, "A megatrend is brewing that could make bureaucratic hierarchies, middlemen, and gatekeepers everywhere obsolete, including social networks, banks, stock exchanges, electronic voting systems, and even governments. It's called decentralized computing, and it could fundamentally transform the way we connect to and exchange value on the internet." There are 3 technologies that will form the foundation of the decentralized computing stack: mesh networks, decentralized networking; blockchain, decentralized transactions; and autonomous agents, decentralized decision-making, unquote. He then goes on to describe each of these technologies in detail, and I encourage you to check out the link in the show notes and read the full article online. He ends the post by saying, quote, "The transition to a global system that is decentralized, distributed, anonymous, efficient, secure, permissionless, trustless, resilient, frictionless, almost free, with no single point of control and no single point of failure, seems inevitable." As the Internet of Things slowly takes shape, an estimated 50 billion devices are expected to come online by 2020. They will be powered by autonomous agents, transact on top of the blockchain, and connect to each other via mesh networks. As more of the decision-making moves from the application layer down to the agent layer, the global system will start becoming more intelligent, and that is when things should get really interesting, unquote. Really interesting indeed. No one knows how this will all turn out, though many have tried making predictions. These trends in decentralized computing, coupled with advancements in artificial intelligence and robotics, are pushing us ever closer to the technological singularity, where computing power surpasses human brain power, and the line between technology and humanity becomes so blurred as to become indistinguishable. Will this technological revolution be liberating or enslaving? If decentralized computing wins over the market, we might have a chance at a future free from centralized control. However, if all of this technology is consolidated and privatized behind the walled gardens of corporations and governments, we may be headed towards a future of digital neo-feudalism, where we are all serfs in the digital fiefdoms of the economic and technological ruling elite. The groundwork has been laid for both scenarios, so the dichotomy is likely a false one. People in reality will likely have multiple choices, and which way one goes will depend on a lot of factors, including cultural, societal, governmental, and technological. This is part of the reason why I started P2P Connects Us in the first place. to educate people about alternatives to the centralized status quo and show support for all of the people dedicating their lives to building the free, decentralized future. I would like to welcome to episode 4 of the P2P Connects Us podcast, Greg Slepak of the DNS Chain and OK Turtles project. Greg, welcome to the show.
Awesome. Thank you, John, for having me on.
It's my pleasure, Greg. One of the first questions that I like to ask everyone that comes on the show is, how did you first get interested in peer-to-peer?
Yeah, I was listening to your interview with Brian Vu in preparation for this show, and I heard you ask him that question. And I was thinking, oh, geez, if I have to answer that, I guess I'll have to be honest and just say Napster. Even though Napster was not completely, it wasn't peer-to-peer, it was completely centralized, but Napster introduced the world to this concept of different peers sharing data with each other. And it was unlike anything that had come prior to it before, to my knowledge. Very easy to use. And when people found architectural problems with it, many different new types of networks were invented to sort of address the centralization issues that were occurring with Napster. And from there, I just found all of that fascinating, how people were using technology to share data with each other.
Yeah, that was also kind of my entry point, not Napster specifically, but peer-to-peer file sharing and stuff is how the term peer-to-peer first got on my radar. So how did you first become interested in computer security then?
My interest in computer security actually evolved from an ethical, moral, political point of view. It sprouted from a problem that I had with the war on drugs, or rather, all of the problems that the war on drugs created for society. And I wanted to see if I could use my skills to try and combat some of the damage that the war on drugs was causing to people. And so my very first foray into that world was when I decided that it would be nice if people could encrypt their email. And encrypting email is still a somewhat unsolved problem. But I decided to tackle one side of that problem by encrypting it on the end user device, which at the time was laptops, desktop, PCs, etc. And so I made an application called Espionage that allowed you to easily do that transparently. So you could tell Espionage to encrypt mail, and then when the user launched mail, it would ask them for their password. If they entered the right password, mail would open and they would see all of their email, and this was all done transparently to mail. It did not realize that it was accessing encrypted files.
Was this end-to-end encrypted email, or are you just encrypting the database locally?
No, it was not end-to-end encrypted. It's still somewhat of an unsolved problem, end-to-end encrypted email. The closest that we've gotten so far is sort of that's even remotely usable is GPG. But that still is a usability nightmare, and that's sort of the next step for me is to work on making that usable while simultaneously being end-to-end encrypted. DNS chain is going to play a major role in that.
Okay, so what prompted you then to kind of shift gears and focus on identity and the DNS chain project?
I didn't really change gears so much as more sort of continued down the path that I had begun back in college when I decided to start encrypting people's email on their computers on one endpoint. So DNS chain and all of this blockchain stuff is just, to me, it seems like a logical, natural progression from all of that. To be able to do encrypted email end-to-end and encrypted communications in general end-to-end, you have to be able to make it easy for the user to do that. You have to be able to simplify all of the problems that are associated with GPG and end-to-end encrypted messaging. And the biggest problem that is facing that world is authentication. And that is something that seemingly almost only the blockchain at this point in time, as far as I can tell, is best suited for solving that problem. All of the other approaches have various different problems or lacking in some way or another. But the blockchain makes it possible to have a global identity. It solves the so-called Zuko's triangle. Today, the way that encrypted email works, let's pick GPG as an example. In order for somebody to send you an email, they have to get your public key, and that's a usability nightmare. The public key for any individual could become compromised, in which case that person no longer has your accurate public key, or they're using a key that's compromised and being used for decryption and re-encryption purposes in a man-in-the-middle attack. The problem is, how do I get somebody's public key in order to send them an encrypted email? How do I know that that public key is actually belongs to them and is the accurate most recent public key for that person? And just the word public key scares people. Very few people on Earth know what a public key even is, and there's no reason for them to have to know what it is. So what the blockchain makes possible, Aaron Swartz wrote a fantastic blog post back in 2011 where he said that the blockchain squares Zuko's triangle. And what it essentially makes it possible is for me to meet you in person or over the internet and just tell you my name, for example. Just say, "Hi, my name is Greg." And that is all the information that you need at that point to be able to send me an end-to-end encrypted message, be it email or anything else. The blockchain makes that possible. This is how people are already used to and conditioned to sending email. So in order to make end-to-end encrypted email usable, you have to keep it the same. You can't really change how people use email. And the blockchain allows you to do that.
I've actually heard it kind of described that PGP turns a plain text distribution problem into a public key distribution problem. And so it's really cool to hear how blockchains help solve that problem really without, actually compromising on security. We'll get into that a little bit later. Could you describe what DNS chain actually is and what its relation is to the OK Turtles software?
Right. So you had this idea that, okay, so Bitcoin comes along and then people realize that the software that makes Bitcoin possible can be used for all kinds of other different purposes to facilitate all kinds of different types of distributed and decentralized businesses and services. And one of them being this global decentralized identity system. Let me sort of expand on what I mean by a global decentralized identity system. The way that identity works today is identity is Twitter. So that is how identity works online today. It's mostly Twitter. If you search somebody's name on a search engine, and if they have a Twitter account, that will oftentimes be the number one result. And why is that? That's because Twitter has been sort of playing ball with people. They're a centralized service, but they've been doing a very good job of not censoring almost anything. They do censor. Most people would agree that it's fairly reasonable, the censorship that they do. They go so far as even fighting for their users' rights in court. So people trust Twitter, and for that reason, they have become almost synonymous with identity today, whereas before it used to be your website. So these days, Twitter seems to be almost synonymous with identity, and then to a lesser extent, your personal website, maybe something like a different social network, your LinkedIn, your Tumblr, your Facebook. But it's still a problem because we don't know how long Twitter is going to behave. We don't know how long we're going to be happy with Twitter, and by its very nature, a centralized service does not allow you to own your identity. For example, anybody who uses Twitter does not own their username. At any point in time, Twitter can, if they decide that they don't like somebody, shut down their account, and they've done this. Similarly, nobody owns their website today. People think that they own their website, but they actually rent it from an organization called ICANN. And while fairly rare, it does happen when many different websites, for very poor reasons, are taken away from their rightful owners and either sold off to other people or seized by a government, etc. So people these days tend to rent their online identities. They don't own them. The blockchain, on the other hand, makes it possible for people to actually have ownership over digital information, including their identity. It's a very democratic type of a concept in that sense. So if you claim a name, say in Namecoin, which is a blockchain that's dedicated to providing the service of a decentralized distributed identity system. You actually own your name. Nobody can take it away from you. The only way that that would be possible was if, all of a sudden the developers completely changed the nature of Namecoin, and nobody would, go along with them. Nobody would use their centralized version of Namecoin. So at this point, the cat's kind of out of the bag, and Namecoin makes it possible for people to own their identity. This allows people to, without fear of some central authority, post almost, whatever they want. They can associate their identity with a GPG public key. They can associate it with a Bitcoin address to which people can send them money. The blockchain is a wonderful tool for getting rid of middlemen. So where does DNS chain fit into all of this? The problem with Namecoin is that it's very difficult to get set up and running with Namecoin. It is this untapped jewel of potential that has remained mostly untapped because of the difficulty of using it. So if you want to be able to take advantage of all of these, fantastic features that it provides, you could download it, and then you could have it running on your laptop. But the problem there is that you have to have it running 24/7 to, make sure that it's synchronized with the network. And for most people, that's already a non-starter. You clearly can't have it running on your cell phone because it's too CPU intensive and it has to be running 24/7. Therefore, using up your data plan. So currently Namecoin and all of the identity-based blockchains have been sort of relegated to the realm of system administrators and people who own a server and can run it there. What DNS chain does is it makes the potential of Namecoin accessible to everyone and any device without having to run their own Namecoin node. It's a very simple concept. It basically says, if I can secure the connection between a device and DNS chain, and if I can trust that connection, then I essentially have the equivalent of running Namecoin locally, except I just use it remotely via the server that it's running on. So I talk to DNS chain over a man-in-the-middle proof connection, and then all of the information in the Namecoin blockchain becomes accessible to me, including all of those public keys. And those public keys can be used for GPG. They can be used to make HTTPS actually man-in-the-middle proof. That way, when you visit a website, you can be actually certain to a far higher degree than it's possible today that you're actually talking to the website with nobody in between monitoring that communication. That's the point of DNS chain. That's the problem that it's solving, is it's making these identity systems usable. And it makes them usable for individuals. It makes them usable for application developers. So it's very relevant for anybody who is developing any software that requires the ability to securely communicate with somebody. By combining itself with Namecoin, it solves the problem of authentication.
That's awesome. In the DNS chain and OKTurtle's white paper, you mentioned that this software provides meaningful security, and you just mentioned in your description that the connection between a user's device and DNS chain is essentially man-in-the-middle proof. So can you explain what quote meaningful security is, how DNS chain provides meaningful security, and then how that compares to the security of web technology that most people are already using?
So in the paper, I tried to essentially coin a phrase called meaningful security. And I use that term to refer to systems that provide individuals security from today's threats, from the sort of global mass surveillance threats that people face today in reality. And any system that cannot protect users from those threats, that protects them from only some actors but not all actors, I don't consider it to provide meaningful security. And the types of threats that users are faced with today imply certain features be available in these secure communication protocols. And I identified 3 essential features that have to be present in a secure communications protocol for it to provide users with meaningful security. The first is end-to-end encryption. That basically means that when I send a message, it's encrypted locally on my device, and nobody in between me and the person I'm communicating with, or the entity I'm communicating with, is able to decrypt that message. That there are no, secret or, golden keys or master keys that allow a company like, Apple, for example, to decrypt all iMessages. That's the case. So iMessage, for example, would be a protocol that does not provide meaningful security because Apple holds those keys. The second is secure authentication. So that's basically where DNS chain steps in. Secure authentication means that I've authenticated the person that I'm communicating with, that I'm actually speaking with the person that I think I'm speaking with nobody in between. So it actually goes hand in hand with end-to-end encryption. It's required for end-to-end encryption to be possible. And then there's perfect forward secrecy, which is a different concept, and it's to protect from what's known as a warehouse attack. So today we have these government intelligence agencies that are simply storing all of the encrypted communications that they receive, so that in the future, when it may be possible to crack these communications, they can then be decrypted and used potentially to attack some individual. So the purpose of perfect forward secrecy is to combat this problem of the NSA and various other intelligence organization communities storing all encrypted communications for the purpose of being able to crack it in the future when computers are faster or some new novel technique is found. So you first establish a secure communication channel. You use that channel to create shared secrets that's known only to you and the person you're chatting with. And then you use that to create new keys as you're talking to them to encrypt messages. And these keys are forgotten. They're not stored anywhere. They're called ephemeral keys because of that. So all of these new messages that are happening, the data that's needed to decrypt them is thrown away after the communication has happened. And so even if the NSA is storing all of this communication, it does not matter, in other words, that they're doing that, because the data that's needed to decrypt that communication no longer exists. It was discarded, thrown away. Not even the people who are communicating, after the fact can access that data and decrypt it. The only way they would be able to do it is if they did not follow the protocol and actually saved all of those ephemeral keys.
How does DNS chain and OK Turtles meet this meaningful security criteria?
So DNS chain makes it possible to have secure authentication, and therefore it makes it possible to have end-to-end encryption. That's the missing link, the missing puzzle piece that it fills. DNS chain allows people to easily obtain the accurate, up-to-date public keys for any entity, be it an individual or a website, without having to rely on any untrustworthy third parties. The way that HTTPS, for example, works today, we have a video, a little cartoon on our website that puts it into more layman's terms on okturtles.com and in the future okturtles.org, is that your web browser relies on several hundred entities, and taken together there are actually over 1,000 entities that are able to forge keys for any website and have web browsers trust that information and tell the user that the connection to this website is secure, even though it's not. A fraudulent key was issued by one of these thousands of certificate authorities that are out there. The blockchain doesn't have that problem. The blockchain is secured by proof of work, and because of its properties, you essentially have trustworthy data. There's no trustworthy entity, there's just trustworthy data that's secured by this algorithm called proof of work. So there's no human element essentially to it that anybody needs to rely on to trust. The only trustworthy entity that exists with the DNS chain model is the DNS chain server that you're connecting to. But unlike today's system, users actually have reason to trust the DNS chain server. They have legitimate reason to trust it, because either they own and operate that DNS chain server themselves, or it's one of their close, trustworthy friends who is operating this server. And we're sort of building up to that. Right now it's in its infancy. Obviously, there are very few DNS chain servers running out there. The point is to make this technology more usable and to get it running on more and more systems, and potentially even running on somebody's home router. A lot of people discount DNS chain because they think it's not feasible for every group of friends to have their own DNS chain server. But there's really not much stopping that, because already every group of friends owns and operates their own Linux server without realizing it. Pretty much every home in America has a home router, and that little box could someday come with DNS chain installed on it. And if that were the case, then the people living in that home don't need to ask their internet service provider. They don't need to trust anyone that they don't trust to be able to securely access any website that they want to access without the threat of a man-in-the-middle attack. And they would be able to securely send email and various other forms of secure communication to their friends without having to rely on untrustworthy third parties that could potentially man-in-the-middle the connection.
So earlier when you mentioned that the connection to the DNS chain server was man-in-the-middle proof, is that what you're referring to? Are you referring to it as such because people implicitly trust, like, I know for a fact this is the right server because I'm directly connecting to it. I know the person operating it, or I'm operating it myself. Or are you saying that like a stranger could operate the server and somehow the connection is still man-in-the-middle proof?
It's an explicit form of trust where they need two pieces of information at the moment to be able to have a man-in-the-middle proof connection to their DNS chain server. One is the IP address of the server, and since it's a DNS server, they kind of already need to know that. For example, many people know Google's very memorable DNS server IPs, which are 8.8.8.8. That's one of them, and the other one is 8.8.4.4. Many people, every home, almost every home these days has some kind of semi-technically savvy, child who knows how to set up a router and can change the DNS server's IP there. And in the case of a DNS chain server running on a router, you actually wouldn't even need to set the IP because DHCP would automatically bootstrap the entire family to that router. They would not need to know what its IP is. It would be the operating system would already set all of that up for them. And then the second piece of information that's needed is the DNS chain server's public key fingerprint. So these two things can be automated to a large extent, with the example of a router. For example, you could imagine buying some sort of future open hardware router, and when you receive it, or if you say 3D print it at home, it has already on it some kind of like an image that you can take your smartphone and basically photograph, and that image contains all of the information the phone needs to be able to securely communicate with that router. So they don't need to know the IP, they don't need to know the public key fingerprint. But the point is that yes, at some point you're going to have to trust somebody. If you don't trust anybody at all, you're basically out of luck. There's no system that there's no possible system that will allow you to have a trustworthy communication if you don't trust anybody. So the point of DNS chain is to severely limit by orders of magnitude the number of entities that need to be trusted. From thousands to one. So if you can find a single trustworthy DNS chain server, and you can do that by running it yourself, or having your nerdy friend run it for you and using their server. Certainly, people I think won't argue that they would trust their friend more than they would trust their internet service provider, or that they would trust the NSA who can manipulate their internet service provider. So their DNS chain comes with reasons, actual reasons to trust the server.
It's an interesting security model, an interesting trust model. I'm familiar with a lot of the stuff that's happening in cryptocurrency, and one of the marketing terminology, as inaccurate as it may be, is that a lot of this technology is trustless. However, it's more like trust-less rather than just as one word, trustless. It has less trust that's required, even though there's still trust that a majority of the hashing power is not colluding against you to, like, say, do any of the 51% attacks that can happen against a blockchain. So with that said, I want to talk a little bit about the security of the database that all of these public keys and identity information is being stored in. Say Namecoin, for example. I believe 70% of Namecoin's hashing power, or the computing power that is securing the Namecoin database, comes from Bitcoin. It's being merged mined with Bitcoin. And there are some concerns in Bitcoin itself that a lot of the hashing power is being centralized into the hands of a few mining pool operators. And even to this day, Bitcoin itself has a very low market cap relative to other companies or budgets of certain kind of government organizations. So do you see this kind of being like a proof of concept right now that will eventually scale into a level of security where no one entity will realistically be able to attack this, or do you think that we're ultimately going to have to build another system that can withstand billions of dollars being thrown at it by any three-letter agency out there that doesn't like what this kind of technology is empowering people to do?
Yeah, that's a very full question, and there were a lot of little things in there. Before I forget, I'd like to make a comment on that terminology, that little keyword of trustless that you brought up. That word comes from the concept that I was talking earlier, where you don't, with the blockchain, you're not trusting on any living entities. You're trusting the proof of work that's protecting the blockchain. In other words, you're trusting that this algorithm is doing its job to maintain the integrity of the blockchain. And sure, it is possible to have a system that instead of using DNS chain where you have to trust one entity, to have a system where you just rely solely on the blockchain. The problem is that right now currently no such system exists that's usable. To be able to use Namecoin in a trustless way, you have to run a Namecoin node on the machine that you are using. So you would, in other words, have to run Namecoin on your cell phone, and that just cannot be done at present. There are ideas out there on how to make that more feasible. One of the most promising ones is called ultimate blockchain compression for unspent transaction outputs. That buzzword. So that hasn't been implemented, though, anywhere yet. And it's still, even say if at some point in the future somebody does implement that, it's still unclear how feasible that would remain to have these kinds of secure light nodes running on a cell phone. They would still have to be running a node that is communicating with the network 24/7 to remain up to date. And that's really something that servers excel at, not end-user devices. So even if, say, at some point in the future, somebody manages to get a system that uses that technology up and running, I suspect that DNS chain will still be a preferable model because it requires almost no effort, pretty much, from end-user devices to be able to access this information securely in this kind of trustless manner, with just one bit of trust to that DNS chain server. Again, there's reason at least to trust it. As to your question of will in the future there, and correct me if I'm misunderstanding, will in the future there be some entity that tries to do a 51% attack with malicious intent on these blockchains? Will they be able to mess with the integrity of them? The good news is that compared to today's systems, the damage that can be done with a 51% attack, a successful 51% attack, is fairly minimal. The damage essentially starts at the point when the 51% attack happens. But any of the information that's in the blockchain prior to that point in time, that nodes have downloaded, all of that information remains secure from the attacker. Say you were using Namecoin and you wanted to access Twitter and a 51% attack occurred. First off, it would likely be detected, so the internet would be going bonkers about it. Twitter's public keys to twitter.com, you would still likely have the accurate keys for them, and you would do so until they decided to update them. At that point, the 51% attacker can prevent Twitter's updated keys from entering the blockchain. But even then, that doesn't allow them to invent new keys for Twitter because only Twitter holds the private key. A 51% attacker doesn't, magically gain access to everybody's private key. So the most that they can do at that point is censor the network pretty much and double spend and things like that. But it's still extremely secure, even in the face of a 51% attack.
Okay, that's really good to know. So Us Bitcoiners. I'm a Bitcoiner. Us Bitcoiners, I believe Peter Todd has called us a InfoSec cargo cult. So we just love geeking out over these really crazy scenarios of like super like alien attackers coming at our blockchain and us having to do like crypto kung fu to protect our blockchain and private keys from attackers. We've established that a 51% attack at most could maybe censor new entries into the blockchain with very little ability to actually mess with the integrity of the data that's actually already in the blockchain. One other threat that's a little bit different than 51% attacks would be like quantum computing. I assume that this system is not quantum proof, and do you think it needs to be for it to be successful?
I am not at the moment an expert on the question of the role that quantum computers can play in the security of internet communication protocols. I hope to at some point be, because it's a very important and relevant question. And just from secondhand accounts, I've heard that quantum computers could, in the future, pose significant threats to today's encryption protocols. But that is hearsay at this point in time that I cannot vouch for. I would say that if that proves to be true, certainly, yes, we would need some kind of new algorithms that are quantum proof.
Okay, that's good to know. So if anybody out there is concerned about this stuff, start investing in quantum cryptography now, like yesterday. How can people learn more about the software and kind of what's coming next?
So there are two projects that are involved in this. There's DNS Chain, and then there's OK Turtles, both of which are under the umbrella of a nonprofit called the OK Turtles Foundation. Currently, most of the development has been focused on DNS Chain, and the audience for that is very different than the audience for OK Turtles. OK Turtles seeks to make a secure, man-in-the-middle proof communication online accessible to basically everybody, anywhere, over arbitrary websites. And it relies on DNS Chain. So first we're going to, build up DNS Chain and then focus on this other OK Turtles part. And, it might even turn out to be that we don't have to do that because, there's already a lot of people who are implementing software for doing secure communications stuff, including on arbitrary websites. There's Mailvelope, for example. There's Google's end-to-end encryption project. I'm sure TechSecure, they're planning on making a web browser extension. All of these different projects, and I should give a shout out to GPG Tools, of course. All of these different projects stand to benefit from DNS Chain, once it's fully sort of finished and built. So as far as next steps, we're going to focus on continuing to add features to DNS Chain to make it a very useful tool for all of these different developers. We recently announced completed rudimentary support for BitShares DNS, also known as KeyID. That's another blockchain that competes with Namecoin. DNS Chain is blockchain agnostic, so we are happy to support any blockchain that wants to do identity. So, that includes, for example, Ethereum. And there's also a Nextcoin fork out there that is in development, hasn't been integrated into the master branch yet. The point of DNS Chain is to make it very, very simple for applications and users to access the information in these blockchains. So that's what we're going to be focusing on, as well as this concept of identities that people actually own. This is a new thing. Most people don't know, like I mentioned earlier, that they don't actually own their identities. They don't own their website domains. They don't own their social media accounts. So that's one area we'll be focusing on, is to make it commonplace, the notion of actually owning your identity and being able to access it anywhere, on any computer, anywhere in the world. There's a lot of fun stuff that's going to come out with that. Some of it I don't want to talk about at this point in time, but it's all free, open source. In other words, there's no product. It's a nonprofit, and anybody who's interested in working with us, whether it's to work on DNS Chain or whether it's to take advantage of DNS Chain for their secure communications tool or project, is welcome to contact us, join us on IRC, join us on the forums. All of that information is available on the OK Turtles website at the very bottom. Click Community. It's also available on the DNS Chain GitHub page. Go to the bottom, click Community. We're happy to work with everybody on this.
Awesome. So if people are interested, they can go to okturtles.org and find all of the information that you just referenced there. Greg, thanks a lot for coming on the show. It's been a pleasure, and best of luck with your projects.
Thanks so much, John. It was a pleasure as well.
Thanks for tuning in to this week's episode of the P2P Connects Us podcast. If you have any comments or questions, you can reach me through the contact page on my website at p2pconnects.us. Till next time.